My name is Kashir Dolatshai. I'm a member of technical staff at Fairchild Semiconductor, motion tracking division. I worked on the ASIC design for the 6D inertial sensing, and it is used normally in drone markets, mobile applications, and industrial applications. The top three challenges that I faced in this design were low power, the geometry, and the performance. The low power was important because our device is targeted for the battery power or mobile application. The geometry was very important because the smaller devices, they wanted to take advantage of our design. And the performance is important because our device has to kind of respond fast in an environment that is rely on the information that comes from our device, basically. Low power is important because our device is targeted mobile and low power environment and the devices. Normally our device has to operate where battery is powering the system. And our devices are going to be analyzed based on the power and efficiency. So we analyze our devices based on the low power, and we try to analyze it as early as possible, because the sooner we know the issue in our device, the sooner we can address it. And knowing the power analysis at the RTL stage, we can prevent costly redesigns. Joule helped me to analyze my design in terms of early power estimation. So I was able to look at the RTL and estimate the power for my RTL, because the sooner I know the issues in my design, I could actually address them. So Joule's helped me to deep down inside the design to figure out what the issues were. And I was able to actually generate power reports that could answer the question, what was my maximum power peak and what was my power usage during the operation. The power peak was really helping the analog designers that designed the regulator for digital block to fine-tune it. And the total power usage was again helping us to determine whether the digital can actually meet the total specification at the top level. So Joules basically helped to determine what was the power consumption, and using that result, I could go back and fine-tune the design at the RTL stage and push that result forward through the synthesis and to the back end, through the netlist basically. And at the end, we were able to correlate and verify that on the silicon. And that actually caused us to be able to meet the power specification requirement for that design for the market that it was targeted for. Experience with Joules kind of showed that the earlier we can start analyzing the power, the sooner we can address the issues in our designs. Setting up the Joules was very easy. It actually fits with RTL compiler setup. So the learning and the ramp up was fairly quick. It took about like a day for me to set it up and start running Joules basically, because I had familiarity with RTL compiler and I could actually transfer all of that knowledge into setting up Joules and using it. There are actually some of the commands are shared, so I could actually benefit from that.